Good day, friends. We shall be talking about hybrid and transmission parameters in these few slides, and that include inverse hybrid parameters. Transmission parameter is also known as capital letter A, B, C, D parameters, and the inverse transmission parameters is also the small letter A, B, C, D parameters. There are some configurations of two-port network in which impedance and admittance parameter cannot be used to analyze. They can't handle such configuration of two-port network. So in such cases, hybrid parameters can be used. Hybrid parameter does not have a specific unit because it's a mixture of different ratios. We have admittance, impedance, current, and voltage ratio all mixed in hybrid parameter. So there are different ratios. So there's no specific unit, just like we have ohms for impedance parameter and Siemens for admittance parameter. So there is no specific unit for hybrid parameter because it's an hybrid combination of different parameters, hybrid of different parameters. In hybrid parameter, we have impedance, we have current ratio, we have voltage ratio, we also have admittance. So the formula of hybrid parameter is simply V1 equals to H11 I1 plus H12 V2. Again, V1 equals to H11 I1 plus H12 V2. And I2 equals to H21 I1 plus H22 V2. V1 and I2 they are dependent variables. In that formula, or for hybrid parameter, V1 and I2 are dependent variable, and your I1 and V2 are independent variable. Also note that when you have your current to be equals to 0, then you have an open circuit condition. And when you have voltage to be equals to 0, remember that circuit becomes short circuit when you have a voltage to be equals to 0. So in such case, if you want to get your H11 and your H21, that means your voltage will be short circuited. That is, your voltage will be equals to 0. Likewise, if you want to find your H12 and your H22, your I1, that is your current, must be open circuit. That is, your current must be equals to 0. Subsequent slide, we also show that further. The matrix form of the hybrid parameter formula stated in slide 2 will give us V1 I2, that is 2 by 1 matrix, equals to H11, H12, H21, H22, that is 2 by 2 matrix, multiplied by I1, V2, 2 by 1 matrix. And that can simply be written as the matrix of H multiplied by I1, V2. So the hybrid parameter is also called H parameters, and is hybrid because, just like we said earlier, it's a combination of different ratios. And hybrid parameters are used in describing electronic devices such as transistors. Remember, hybrid parameter is also used in analyzing ideal transformers, just like we have impedance and admittance parameter being used in synthesis of circuit, impedance matching, and distribution of power networks. So hybrid parameter is used in describing electronic devices such as transistor and also in ideal transformer. So we have from our formula stated in slide 2, V1 equals to H11 I1 plus H12 V2, and I2 equals to H21 I1 plus H22 V2. From that formula, we can get our short circuit input impedance, which is H11, can get different variables of hybrid parameters, different values of the hybrid parameter, we can get it. But the first one, which is short circuit input impedance, which is H11, and that will give us V1 over high 1, that is H11 equals to input voltage over input current, provided that your output voltage is short circuited, that is your V2 equals to 0, and that is simply short circuit input impedance. And also your open circuit reverse voltage gain, that is your H12, will be equals to V1 over V2 input voltage over output voltage, provided that your input current I1 equals to 0. Also, your H21, also called short circuit forward current gain, will give us I2 over high 1, provided that your V2 equals to 0. No, I2 simply is the output current over input current, provided that your output voltage equals to 0. Also, open circuit output admittance, that is H22, is equals to output current over output voltage, that is I2 over V2, provided that your input current I1 is equals to 0. Now we can see that hybrid parameter is a mixture of different parameter and also different ratio, and this simply shows that our H11 is, as we see it, is an impedance parameter, our H12 is a voltage gain, and our H21 is a current gain, then our H22 is our admittance, making it a mixture or combination of different parameter. Now, for hybrid parameter, we have the reciprocal situation, or the reciprocal network for hybrid parameter is H12 equals to minus H21. Remember, for impedance parameter, our reciprocal network is Z12 equals to Z21, and for admittance, it is Y12 equals to Y21. But for hybrid parameter, the reciprocal network is H12 equals to minus H21. Negative sign is the only difference. Now, the assignment I will give to you is, do we have symmetrical network for hybrid parameter? Give reason. If yes, if no, give the reason. If we have symmetrical network for hybrid parameter, state the reason. If not, also state the reason. That will be our assignment in that. And also for the model of hybrid parameter, that is the different combination of elements there, we'll go to slide 5 to see. This slide simply shows the equivalent network of hybrid parameter for two-port network.